Here's a look at some different ways to achieve the same outcome using different parts of the technology.
So now I'm going to show you a different way to solve the same problem. The second one, we're going to use constraints or Boolean logic to overlay onto the model. What we've done is add in a new endpoint called node_t. What you'll see is that we have a little hexagon here. We have some rules defined here. Associated with each block in the assignment, we've picked up have t yes, have t no, like so, and we've done that for each of the data states. You need to go in and define a rule. And we've created a very simple one here. So if any of these is not true, we cannot make a cup of tea. So if we don't have boil kettle yes, or have kettle yes, or power yes, or tea, then we will be unable to make a cup of tea. You'll see previously we had 4 tests, but previously we were just picking up any one of the 4 states and saying any one of those, and we will not be able to make a cup of tea. So you will end up with the largest set of potential reasons to not have a cup of tea. Now, whenever you use a rule and you want to go down onto the next part of the model, what we have to do is create the opposite. And then what we have is a rule here, just basically saying if all of those are set to yes, 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 and yes, into the next set of logic. No milk, no sugar, etc. So we haven't had to double up in this case. Here we've just added the process add milk and add sugar. And what you'll see right at the end, we have perfect tea and imperfect tea. And we have our rules. So let's have a look at perfect tea. And what you have here is a more complex Boolean logic. And this is basically a kind of nested and. And what we're saying is we want milk equal to want milk, have milk equals to have milk. That's great. Or want milk is not equal to want milk. If we don't want milk, great, we carry on. And we've repeated it with sugar. Both of these getting into some relatively complex and/or logic. If we go to imperfect tea and we look at rules, want milk equals to want milk, have milk not equal to have milk, and either of these is true, we're not going to get the perfect cup of tea. If we go and look at perfect tea and tests, there are 9 of them, which is pretty much what we had before, and imperfect tea, 7 of them. Now, if we look for all tea, due to the logic at the beginning, where we're forcing through all the potential variations of the 4 data states, we will end up with more potential paths just to get through there.